Welcome to Excellent Grades Academy. This is Dr. Byson AM. Today we're doing organic chemistry and we're looking at tutorial sheets 2 specifically. Okay, so let's get into this video and then solve these questions. So this is from the University of Zambia School of Natural Sciences, tutorial sheet 2. And you are required to know all the answers in this tutorial sheet because they will be part of your continuous assessment in your quizzes. So pay attention until the end of this video and learn. Okay. So question 1 is, from the given pairs of molecules below, choose which one is a stronger nucleophile. Okay, which one is a stronger nucleophile? So the main question here is, what is a nucleophile? So what is a nucleophile? It's a very important thing to know the definition of a nucleophile. So if a nucleophile, so this is a species. So it's a species or a compound that is composed of, a pair of electrons. A pair of electrons is what we call a lone pair of electrons. So a lone pair of electrons or is negatively charged. So a nucleophile has got a greater affinity for the nucleus of an atom. That's why it is called a nucleophile. Okay, so you know that the nucleus of an atom has got protons, and protons are negatively charged. So whenever a molecule or a species has got a lone pair of electrons or is negatively charged, those lone pair of electrons or the negative charge will be seeking after the nucleus of another atom because the nucleus has got positively charged particles which are protons. Okay, so now the group of atoms or a species that a nucleophile attacks is what we call an electrophile. So in organic chemistry, you really need to know these terms because they are very important. So an electrophile is simply a species that is positively charged. So it is positively charged or has a higher quantity of protons or has a high quantity of protons. Okay, protons, or is partially positively charged. So a nucleophile will always attack an electrophile, and an electrophile will always be seeking for negative charge because these two are of different charges. Nucleophile has got a lone pair of electrons. You know electrons are negatively charged or a negative charge. An electrophile will be positively charged or it will be partially positively charged. Okay, now let's look at what they've given us. So number 1 here, you've got ammonia, and this amine group here. So when you compare these two, you know that this one here is a neutral compound, whilst the amine group here has got a negative charge. So just comparing the two, you know that this amine group here, so here, this amine group, because of the negative charge, is a stronger nucleophile. So this one is a stronger nucleophile. But even the ammonia is a nucleophile. Why? Because you know ammonia has got a lone pair of electrons. So it is like this. So it has a lone pair of electrons. Okay. So it is still a nucleophile, but this one has got a lone pair, two lone pairs of electrons and a negative charge. No wonder it is a stronger nucleophile. Okay. Number 2 is hydroxide ion and water. Which one is stronger between these two? The one that has got a negative charge is stronger. So here the OH is stronger. Why? Because the OH has got a negative charge. Number 3, between and a cyanide. So now Between these two, both of them have a negative charge. But when you compare sulfur and nitrogen here, sulfur and nitrogen and carbon, you find that sulfur is a bigger atom compared to carbon. Okay, and the electronegativity of the bond between sulfur and hydrogen, the electronegativity of this bond is bigger. So the electronegativity of this bond is bigger than the bond that exists between carbon and nitrogen. So this is a stronger nucleophile. Okay, this is a stronger nucleophile because the electronegativity of this bond is stronger than the electronegativity of these bonds that are found between carbon and sulfur. What that means is that the sulfur has got a stronger pull on the electrons, so meaning this negative charge is more strong than the negative charge that is created on the carbon here. All right, so this negative charge is stronger than the negative charge on the carbon. Why? Because the electronegativity of the bond between hydrogen and sulfur is stronger than the electronegativity of the bonds between carbon and nitrogen. So that's how you assign the strength of nucleophility in groups or in atoms. All right, let's go to question 1b. So question 1b says, what product will be formed from the nucleophilic substitution second order reaction, SN2 reaction of the following? So number 1, you have 2-bromobutane and a hydroxide ion. A hydroxide ion. So now you write their structures. You know this is carbon number 1, number 2, number 3, number 4, butane. And they're saying it's on carbon number 2. So the bromine is carbon number 2. And you are reacting this with hydroxide ion. So you know SN2, the nucleophile is going to attack this carbon here. So this carbon here is the alpha carbon because that's where the functional group is. Okay. So now this carbon here is partially positive. So this part is partially positive. Why? Because of the attached halogen. This halogen has got more electronegativity than this carbon. So this hydrogen will be partially positive, partially negative rather, and this carbon here will be partially positive. So now this partially positive carbon is an electrophilic center. Why? Because it is partially positive. Remember what we said about electrophilic, an electrophile. So it is an electrophilic center because it is partially positive. This is a nucleophile here. So this is a nucleophile. The nucleophile has got a negative charge. So this negative charge here of the nucleophile will be attracted to the partially positive electrophilic center. So this nucleophile is going to attack this electrophilic center at the back of the halogen. So there's going to be backside nucleophilic attack. And when the backside nucleophilic attack happens, this halogen is going to leave. All right. So when that happens, you're going to have a transition state, which will be like this. So this will be the transition state. In the transition state, this bond will be forming here, and this bond will be breaking here. Okay. So now, in the transition state, you find that the carbon here has got more than 4 bonds. 1, 2, 3, 4. So carbon cannot have more than 4 bonds. So this is a high energy state. So you write 2 positive charge here. 2 positive charges here. That's why transition state has got this sign, because there's too much energy. And what is going to form afterwards is that there's going to be hydrogen that is attached here, and this bromide is going to go. So because it has taken electrons here, it is going to be negatively charged. So this is what is going to form. This is what is going to form in this reaction. It is very important for you to know this reaction. Okay, this is how an SN2 reaction takes place. Let's look at 2 here. So 2 is ARA 2-bromobutane and hydroxide ion. Now when you look at ARA, it means that they have assigned stereoisomerism to this compound. So the bromide is 1, 2, 3, 4. Okay, so ara means that at carbon number 2 here, this is our optical center. And our optical center, there's going to be a 3D orientation. So they say that we have bromine on carbon number 2. So this bromine is going to be in front like that. And then the one that is going to be behind is hydrogen. Okay, so the bromine is here. Now, the reason why I've written it like this is because ara means that you have to assign the atoms that are attached to the electrophilic center here numbers, and then those numbers should rotate in a clockwise form. So you know that bromine is always number 1. Bromine is number 1 because it has a higher atomic number. And then this carbon here will be number 2. This carbon here will be number 3. So the rotation will be from number 1 to number 2 to number 3. So there's going to be clockwise rotation here. Okay, so this is ara bromobutane. This ara bromobutane is going to react with hydroxide. Okay, so this hydroxide is going to attach here. When this happens, this hydrogen is going to attach here, and then this halogen, the bromine, is going to leave. So this hydroxide is going to attack there, and the bromine is going to leave. So what will be formed is this. Okay, so now the substrate that reacted was ara. The product that is formed is supposed to be S. So there's always going to be a configurational change that happens. So if in optical isomerism, if the substrate that was happening was reacting was ara, there's going to be a reversal in the product that is going to be formed. So this, we know that the hydroxide is going to attach on carbon number 2, but ensure that the way it attaches, it is going to give you an S configuration. So if we press the hydroxide here, and then the hydrogen here, this is going to be S 2 butano. Why? Because this is the oxygen is 1, and then this carbon here is number 2, this carbon here is number 3. So this is going to move from here to there to there. So this is going to be anti-clockwise. That's why this is S-butano that is formed. All right. So always remember, if the substrate that is reacting is the ara configuration, the product that is going to form is the S configuration. Okay, so that is how we're going to differ in the products that we are going to get between these two reactions there. Okay. Number 3 says, arrange the following alkyl halides in order of decreasing reactivity in an SN2 reaction. Okay, so A, they've given us to be 1 bromo, 2 methyl butane. So we know that this is going to be butane 1, 2, 3, 4, and bromine is on carbon number 1, methyl is on carbon number 2. So it's supposed to be like this. B, they've given us to be 1 bromo, 3 methyl butane. So we know it's going to be 1, 2, 3, 4. The bromo is on carbon number 1, and the methyl is on carbon number 3 there. C is 1, 2, 3, 4. They said 2 bromo, so the bromine is on carbon number 2, 2 methyl butane, so the methyl is also on carbon number 2, like that. And then D, they've given us to be 1 bromopentane, so this is carbon number 1, 2, 3, 4, 5, and the bromine is on carbon number 1 there. Now they're saying arrange the following alkyl bromides in order of decreasing reactivity in SN2 reactions. So in SN2 reactions, we know that the less substituted alkyl halides react the fastest. Okay, so now we know that in SN2 reactions, first degree alkyl halides will react more than second degree alkyl halides, which will react faster than third degree alkyl halides. That's how it works. Okay, so now let's assign the degrees of these alkyl bromides that they've given us. We know that this is first degree because this the carbon where the bromine is attached here is a primary carbon. This one is also first degree because the carbon where the bromide is attached here is primary carbon. This is a tertiary. Why? Because the carbon where the bromide is attached here is primary. It's attached to 3 other carbons. This is primary. Why? Because the carbon where the bromide is attached here is attached to just 1 other carbon. Okay, so definitely we know that this one here is going to be the lowest. Okay, so we know that C here will be the lowest. Okay, so C will be the lowest. Now let's compare this one, and this one. Okay, so if you look at D here, this our bromide here is attached to this carbon, and this carbon is just attached to this one other carbon, and this other carbon is only attached to 1 other carbon. Okay, so D here will be the most reactive. Why? Because it is the least substituted. Okay, followed by B. Okay, so when you compare B and A, B is less substituted compared to A. Why? Because look at this carbon. This carbon here, that is the alpha carbon where the bromide is attached to this carbon, and this carbon is only attached to 1 other carbon. Okay. But for this one, this carbon is attached to this carbon, and this carbon is attached to 2 other carbons. Okay, so this one is more substituted to this one. So that's why B will be more reactive in SN2 reactions compared to A. So in decreasing order, this is how the bromides are going to react in an SN2 reaction. So D will be the most reactive, followed by B, followed by A, followed by C, depending on how substituted the carbons are, how substituted the compounds are. So that is how we're going to answer question 1 in this tutorial sheet. If you didn't understand, go through the video over and over again until you understand, and I'm going to do the last question and then that will be it. Okay, D. When methyl bromide is reacted with sodium hydroxide, methanol is produced. Name and write a detailed reaction mechanism for this reaction. So we said we have methyl bromide. Methyl bromide is like this. This is methyl with unattached bromide. And then we say this is reacting with sodium hydroxide. So we know sodium hydroxide is an ionic compound. So the sodium is positively charged and the OH or the hydroxide is negatively charged. So we know that the OH is the nucleophile. Okay, so now this is a methyl halide. Methyl halides preferably go through SN2 reactions. So the name of this reaction is SN2 reaction. Nucleophilic substitution by second order. So nucleophilic substitution by second order. How this reaction is going to take place is that this nucleophile is going to attack this methyl bromide at the backside. Contrarily, backside in relation to where the nucleophile, to where the leaving group is, and then this leaving group is going to leave. When that happens, first of all, they're going to form a leaving group. They're going to form a transition state. So the transition state is going to be like this. Okay. So always do not forget to draw the transition group. the transition state. So this is the transition state because it carries marks in your tests and in your exams. Okay, so we put two positive pluses here because it has a high energy state. It is a high energy state. Why? Because carbon temporarily has got 5 bonds. That's why. Okay, so the product that is going to form is this one here. So the OH is replacing the bromide. So this is the product that is formed. This is methanol. Okay, plus the bromide that remained, the bromide that left, and we know that in the solution we've got sodium, which is this one here, which is this sodium that remained after the hydroxide went and attacked the substrate. These two will combine and they will form sodium bromide. Okay, so that is how the reaction is going to take place. So this is one here. Number 2 says, give the rate law for this reaction and state the overall order. So the rate law is given like this. Rate is equals to K. What is reacting is the methyl bromide and the hydroxide. Okay, so now in an SN2 reaction, both the substrate and the nucleophile take place in the rate determining step. So they are both involved in the writing of the rate law. Okay, so this is the rate law. So there's a substitute 1 here, there's a substitute 1 here. The overall order for this reaction, is 1 plus 1, because there's subscript 1 here for the alkyl halide and the subscript 1 here for the nucleophile. So the overall order here is 2. Number 3 says, what happens to the rate when the concentration of the nucleophile is doubled? So you double the concentration here. Instead of 1, you just put 2 here. So what will happen to the rate will just be 1 times 2, so it will double. So number 3, if the concentration of the nucleophile is doubled, the rate of the reaction also, so it also doubles. That's how it happens. Okay, so in an SN2, if the concentration of a nucleophile is doubled, the rate of the reaction also doubles. Number 4, what happens to the rate when the concentration of the nucleophile and the substrate are doubled? So if the rate law is like this, okay, we know that methyl bromide had subscript 1 and also the nucleophile had subscript 1. So if you double both of them, it means that this will be 2 times this one will be 2. So it will be 4 times. So if you double both of them, so if the concentration of the nucleophile and the substrate is doubled, so they're both doubled, then the rate will quadruple. So the rate is going to quadruple. Why? To be 4 times. Okay, so the rate will quadruple. It will be 4 times. So that is how you are supposed to answer question 1. I hope this was helpful. Look out for question 2, question 3, and question 4 in the next video. I'll see you in the next video. Do not forget, you can subscribe and register at our academy, Excellent Grades Academy, on +2609754977790. Let us learn organic chemistry and all the courses in second year together. I'll see you in the next video.